Hi dear friends, good morning to all. Dear friends, in the previous part of the video, we discussed about one important device called as nuclear reactor and the power reactor. The main difference between nuclear reactor and the power reactor that we discussed in the previous part, difference only is that whenever the nuclear reaction is carried out in a controlled manner to obtain energy, then the device is called as nuclear reactor, and if this nuclear energy is converted into electrical energy, then the same device will be called as power reactor. Dear friends, in the previous part we discussed about the various essential or important components of power reactor, and before that we also discussed about the nuclear reactor. Dear friends, today in this part of the video we are going to discuss about a construction and the working of power reactor, which is one of the important device to convert electrical energy obtained in nuclear reaction into nuclear energy obtained in the nuclear reaction into electrical energy. So dear friends, today to discuss the construction and the working of this power reactor, before that I would like to revise the essential components of this power reactor. So this is the diagram that indicates the overall overall diagram of this power reactor. So here these are nothing but the components of the power reactor, or you can say it is the nuclear reactor in which nuclear reaction is carried out in controlled manner to obtain the energy. Dear friends, if you see, these are some components that we discussed. This is the central part in which the nuclear fuel is placed, that we call it as the core, and these are nothing but the particular nuclear fuel which is present in the form of rods called as fuel rods. Okay, and this is the central part in which the nuclear fuel rods are placed, and that we call it as the core. This core is surrounded by means of some material which prevent the leakage of these radiations, and that we call it as the thermal shielding. And again, the whatever energy is obtained, that will be passed through this pipe, that is which is having the coolant through this steam generator. These are passed to turbines, and from turbines it will be passed to generator, where the steam is used to generate the electrical energy. So it's very important thing that to discuss the various components. If we discuss the another diagram that is given in the text, it is also having the same component, but the orientation is different. Just like the previous one, we can discuss here the component. This is the nuclear fuel, these are the moderators, this is the shielding, these are the control rods, the heat exchanger, turbines, and finally it will send to generators. This is the important components of this power reactor that we discussed in the previous one. I am just going to revise these components. So dear friends, already we talked about power reactor. Power reactor is the device of the furnace in which fissionable material produces energy in the form of heat. It's very important, and it is used to generate the electric power, the electrical energy. And if we discuss about the essential component, you know very well the essential component. The first component is the core, which is the central part in which the nuclear fuel is placed, and the whatever type of the nuclear fuels are used in the power reactor, these are particularly uranium-235, and another one is the plutonium-239. Apart from this, the another components are moderator. It slows down the fast neutrons which are released in the nuclear reaction, and as a moderator, the two different substances, heavy water, that we call it as a deuterated water, or sometimes the graphite is also used as a moderator. Control rods, these are the steel or cadmium boron steel alloys which absorb the thermal neutrons and maintain the multiplication factor K is equal to 1, so the rate of nuclear reaction will be steady. So again, the coolant, the heavy water removes the heat generated, excess is generated in the core of the a nuclear reactor due to the fusion process, and that's called as the coolant. Particularly, water or the deuterated water is used as a coolant. The water substances which are used as the moderator, the same substances can be also used as the coolant. Dear friends, after this discussion of various components of this power reactor, now we are interested today to discuss the construction of the power reactor. What are the, how is the various components of this power reactors are arranged, and how it works, that we will discuss in the working. Before discussing the working, we will discuss about the construction, and here this during the construction we will come to that this power reactor consists of blocks of carbon that is in the form of graphite. I hope you can remember this is one of the allotrope of the carbon, and that's why this power reactor consists of the blocks of the carbon in the form of graphite, which is surrounded by thick walls of the shield, and some holes are bored through these graphite blocks to supply material. So whatever material has to supply, that can be supplied through this bore, and it is also used to provide the control also. Again, if we discuss about the construction of this power reactor, then you will come to that some aluminum boxes contain uranium-235 in the form of long pins in the form of nuclear fuels, and these containers are placed in alternate rows of blocks. So here this is the just arrangement of nuclear fuel in the core of the nuclear reactor, in the central part of the nuclear reactor, and some coolants like deuterated water is circulated through the pipes around the nuclear fuel or the fuel core. It removes the excessive heat away from the reactor. So this is the simple. Again, just like the various components of the power reactor, this power reactor consists of the rods, particularly cadmium rods, which are used as neutron absorber. I hope you can, these are the control rod which absorb the excess number of neutrons, thermal neutrons, and they control the neutron density, means number of neutron, and temperature of the nuclear reactor. So the definitely this nuclear reaction is a chain reaction, and the number of neutron must be controlled, otherwise it would be very dangerous to carry out this nuclear reaction. And this is controlled with the help of this cadmium rod, because these rods are responsible to absorb the neutrons. If we discuss about the working of the same nuclear reactor, then you will come to know that this power reactor works in the same way just like the nuclear reactor. In the first, or in this case, initially the neutrons are obtained, because neutrons are, these are the particles which are used to bombard on the target. That's why the target will be converted into newly daughter nucleus. And in this case, if we'll discuss here, these neutrons are obtained in this reaction. So these neutrons will be used for nuclear fusion, and we will obtain the energy. So these are used as bombarding particles, these are used as the projectile, and these neutrons are obtained by the reaction of particles on, or by the bombarding of particles, particularly these helium particles, alpha particles on beryllium, and during this beryllium will be converted into carbon 12. And during this reaction there is a liberation, or there is a formation of neutron, and these neutrons will be used for the nuclear fission. And the speed of this fast moving neutron is reduced by passing them through the graphite block, which acts as the moderator, because the function of the moderator is to reduce the speed of fast moving neutron, and that's why here the graphite blocks are used as the moderator. So these are responsible to slow down the fast moving neutrons obtained in the nuclear reaction. Again, when these neutrons collide with the uranium-235, so this uranium-235 is the target, and these neutrons, slow neutrons, are a projectile. Definitely these are bombarded on this neutron, and whenever these neutrons are collide or bombarded on this uranium-235, So these neutrons, whenever bombarded on this uranium-235, these neutrons are responsible for the fission of this uranium-235. So this nucleus will be splitted, will be broken into two parts. One, that's why this uranium-235 will be broken down into two smaller nuclei of the same size. One is the barium and another one is the krypton. At the same time, there is a liberation of more than one neutron, which are the first neutrons, with the liberation of large amount of energy. And this energy is very important in this nuclear fission. And again, these neutrons are slowed down by the moderator, and these will be responsible for the fusion of another nuclei, and that's why these neutrons are responsible for what? These are responsible for the chain reaction. So it is the continuous process. Unless and until the neutrons are there, the same process will be repeated again and again. So it is the continuous and the chain reaction. But during this fission of uranium-235, in presence of this neutron, there is a liberation of large amount of energy, 300 million electron volt. Dear friends, so this loss of neutrons from the surface of this nuclear fuel or the nuclear material can be minimized by increasing the volume of graphite block. It's very important. So loss of this neutron, because neutrons are responsible for the nuclear fission, and this loss of neutron from the surface of nuclear material can be minimized by increasing the volume of graphite blocks. So whatever graphite blocks are used, if we will increase their volume, then the loss of neutron can be minimized. And the pipes carrying the coolant, because for pipes through which the steam or the heat generator that is flowing, or the energy is flowing, then this pipe carrying the coolant at a high temperature and pressure are passed through the heat exchanger. So these pipes are responsible to prevent these are responsible to prevent this heat loss of heat. Actually, these pipes carrying the coolant, these are responsible to reduce the temperature of this heat which is passed to this exchanger, or these are responsible to decrease the temperature of this central part of the core. The excess heat can be decreased, or this excess heat can be removed with the help of this pipe carrying the coolant, and where heat is transferred to water. And once these pipes carrying the coolant, particularly water, through that is at high pressure and temperature, pass through the exchange. So definitely there will be the exchange of heat from this heat exchanger to the coolant which is present in the pipe, and this coolant is water. So definitely the temperature of this coolant means the water will increase, and this heat is transferred to water, and this water will be converted into steam. So this is it means that we can say that the whatever energy is released in the nuclear fission, this energy is transferred to coolant through this heat exchanger, and this coolant, particularly water, will be converted into steam. It means that we can say that nuclear energy get converted into steam of the water, and the steams will be used for the next purpose. So whatever steams obtained, these steams are passed to the steam turbine, and once these are passed to steam turbines, this turbines runs an electrical generator or the electric generator, and this electrical generator or the used steam in this electric generator goes to coolant. So once this steam used, this goes to coolant, and it will be condensed, which converts steam into water, because once the heat is used by the electrical generator, definitely this used steam will be passed to again coolant, where it will be condensed. So once the steam is condensed, so definitely it will be again reconverted into water. So we are getting the product. This water is pumped back to the heat exchanger. I hope you can you can understand this process. If you see the that is a diagram of this power reactor, then you will come to that how this is the condition, because here you can observe here this how this is recycled because the water definitely heat is generated here by means of this nuclear fuel, and once it is generated, so this energy is passed through this. I hope you can understood, passed through this. But here this is the hot cooler in the sense, because this heat is transferred to heat exchanger, and from the heat exchanger it will be transferred to the coolant which is present in this pipe, and it is converted into, so due to this heat exchanger it will be converted into steam. So steam is generated in this part, and this steam will be transferred to what, turbine, and this turbine, once it is passed to turbine, and these turbines use this steam for, and it will be passed to use for electric generator. So this is, and this electrical generator will convert this, once it will produce the electric power. But here again, this some of the waste steam which is used up here, it will be again passed here, it will be condensed, so it will be cooled down, and again it will be converted into water, and this water will be pumped again, and it will be again transferred to this steam generator, or that is this part, so where it will be again converted into steam. So this is the recycling, this is the continuous recycling of this steam into water and water into steam through this heat exchanger. I hope you can understand this. It's very simple to discuss the various components and the construction and the working, and this is another diagram you can see here. So whatever, this is again sun, this is the source, this is the nuclear fuel, this is the controller, this is shielding which prevent the loss of this radiations out of this nuclear power reactor, and this is heat exchanger. So whatever energy is produced, it definitely will transfer to it, but this is heat exchanger, and this heat exchanger is connected to what, pipes carrying the coolant. So this heat is transferred to coolant present in the pipe, and definitely this coolant will increase its temperature, and this coolant, particular water, will be converted into steam, and this steam will be transferred to what, turbine, and turbine used this steam for electric generator, and definitely and used steam again passed to this condenser, or it will be condensed with the help of this condenser, so that steam will be again converted into water, and this water pumped back for the heat exchanger, where it will be again converted into steam. So this is the complete recycling process. I hope you can I hope you can understand this very well, to discuss the construction and the working of this power reactor, which is very simple, to discuss the construction and the working of this power reactor, which is used to convert the nuclear energy into electrical power through the formation of steam generator. So dear friends, I hope you understood very well about the power reactor, its various components, and the construction, and most important, the working of this power reactor. So dear friends, in the next part we will discuss about the breeder reactor, and some nuclear fusion nuclear fusion reactions are there. So we will discuss about the breeder reactor and the nuclear fusion in the next part of the video. Thank you very much.